All right, welcome to lecture 12. How did, in general, and I know they haven't been graded yet, but how did the celebration go for everybody in general? Hopefully it really wasn't that challenging. I didn't really intend for it to be like the hardest thing you've ever done, but I wanted it to be as much as possible within 50 minutes, a complete exercise of the skills that we learned over the past couple weeks. Okay? And one of the things I will tell you is that independent of one topic left in AutoCAD, which is the topic of dimensioning, I've kind of taught you everything you need to know in terms of preparing drawings. And when I say I've taught you everything that you need to know, I mean technical-wise, in terms of what buttons to hit, what items to draw, and so on and so forth. To sort of make the point, I just want to bring something up real quick. I drew this on the board a long time ago, and this was just a sketch of a plate with a hole in it. Okay? Now, I guess my question to you all is, could you draw that today? Yeah, you could, right? There's nothing really to it, right? And so if I present you an engineering schematic, you can draw it, right? I think that's fair, okay? What we're going to do for the next few weeks, yes?
What do you mean by thickness? Like the line thickness?
I'm talking about the thickness of the plate, like the part thickness, yeah. But what I'm saying from could you reproduce this, I mean, could you write that text in AutoCAD that says 0.25 inch thickness? And I think by now we all would say yes. What I want to do for the next few weeks is to take the skills that we have learned in AutoCAD and maybe start applying them in some more, like, I would say real world settings. So I want to, I guess my overall point is that for the next few weeks, when it comes to the specific AutoCAD skills and what comes on the assignments, I'm probably going to be a bit less micromanagerial. In other words, the assignments are probably not going to be draw a line that is 1.5 units across at 60 degrees and so on and so forth. Instead, it's probably going to be, here's an object, reproduce it, you know what I mean? Or prepare drawings for this object and so on and so forth. And then you all have the skills necessary that you can do it, okay? So I will probably be light in my specific instructions on AutoCAD and more heavy on, okay, let's actually apply those skills in some settings, okay? Does that make sense? So I just want to prepare you for what's coming. And I'll tell you, today and this week will be a little more loose in terms of work requirements for a couple of reasons. One, it's my first time teaching the class, and the last thing that I want to do is I just don't want to keep shoving material down your throats. I want it to be absorbed, and I want it to make sense. So I started to prepare some lectures for this week, and I was going through the dimensioning lecture, which was going to be our topic this week, and I just remember sitting there as I was preparing it, and I was going, man, it'd be really nice if we could actually look at some engineering drawings. And then I looked at my outline, and we were going to look at engineering drawings, and then I went, wait a minute, I'm the professor, I can rearrange this if I want. So I said, let's do that first, okay? It's a nice little break and respite from all the CAD drawings that we produce, but at the same time, I think it would be valuable to do this now so that when we get into dimensioning and views and sections, there's a little bit more context for what we're about to do, okay? Now, in terms of class logistics and whatnot, just so everybody knows, the attendance grades are up to date. We've got the assignments for week 3 and week 4 graded. I think it's fair to say that you all, as a class, knocked those out of the park. We get A averages on all of those. Homework 5 is being graded. Our goal is to get that done this week. I'm hoping early this week, and then the exam will be graded hopefully by early next week. Again, there's a lot of drawings to get through. Now, I don't have a homework assignment for you today, but the homework assignment this week is not going to be a CAD drawing. It's going to be a quiz or one of those multiple choice, short answer assignment type things that we did at the beginning of the semester. So once you turn in week 7, it should be automatically graded. So my hope is that by next week, we'll be at a point where everything's graded. Like everything's graded. And then we can move forward. I also want to give everybody a path forward to the potential land of margaritas and Mai Tais, and by that I mean spring break. So let's talk about what's going on between now and spring break. So this week, if you want to Instagram this slide, this is a perfect one to take a snap of. So this week, we are going to be going through a plan reading exercise. I'm going to go through the plans a little bit in detail today, and then what's going to happen on Wednesday is I'm basically going to give you all an assignment that's going to require you to review the plans and answer some questions about them. And to be blunt, really the main point is to get you looking at some real world drawings. And given that I've got civils, mechanicals, electricals, you know, it's like what plan set sort of makes sense for everybody, that has a little bit that everybody would like to see. And to be honest, the plans for the building. Like there's a lot in there for multiple different disciplines to glean stuff out of. And plus it's something that I think we're all familiar with. It's something that we can sort of look at the plans and go, okay, I kind of get what they're seeing here. So I thought it was a good set to go off of. Week 8, the theme of week 8 is going to be dimensioning. Okay, so it's basically going to be, if you remember those assignments that we've had up until now, where I gave you a set of schematics to reproduce, it would not have been possible without the dimensions and the annotations at the end. Well, now we need to know how to reproduce those. Okay. Section 9 or week 9 is going to be on scaling and on views and sections. So week 9 I think is really the week where we're going to get a little bit more critical thinking aspect of it. Like I give you a 3-dimensional object and I say reproduce the front, top, and right view of it. And then you're the ones that are going to have to open the drawing and configure it and scale it in a way that makes sense. So it's going to be much more on you as opposed to me saying draw a line that's 2 inches long this way, that way, and so on and so forth. It's really going to be up to you to format that the way you see fit. And then week 10, we have our second celebration. We're going to review on Monday, exam on Wednesday, and then it's spring break. Okay? Does that sound good? Mm-hmm. Sound like a good plan? One thing I will mention, and it is a bit of bad news for you folks with apples, but we just got to get the truth of it out. When we come back from spring break, we're using Inventor. Okay? Inventor is not a Mac-friendly package, it's a Windows package. So you'll probably have to set up an emulation or something like that. I just want to give you a heads up now. So, okay. Any questions? All right. So today, like I said, we're going to take a little break from AutoCAD today. And today we're going to look at some real-world plans. And we've talked about this a little bit. We talked about this at the beginning of the semester when we were first learning about this class. The very first lecture that we had was, okay, let's look at some engineering drawings. In fact, I might pull that lecture up just to sort of like refresh everybody, because I know it's been a while since we looked at that. Let me go up. Let's actually take a look at that real quick, because I'll be brief. So, oh, wrong week. That's the wrong one. It would help if I opened up the right one. That's the one I wanted. Okay, so if you remember, we had opened up this lecture and we said, okay, let's just look at some engineering drawings. And then all I did was I said, here's a picture of a mechanical engineering drawing, here's a picture of a civil engineering drawing, and then the rest of that lecture was really focused on the, I guess what I would call the AutoCAD objects of the drawing. In other words, like every drawing has lines, and it has text, and it has polygons and rectangles and all of that stuff. And yes, that is true. That is important. You cannot construct engineering drawings without those objects. But a bunch of rectangles and offsets and trims and extends and ellipses and all that stuff doesn't make for engineering communication. Engineering communication has to communicate intent. Okay? So instead of really talking about the components of the drawing, I think what I want to talk about today is what's actually in the drawings. And so a lot of this lecture that we had last time was about, the views and scale and dimensioning and all this stuff. So now I actually want to look at some real drawings. Okay? So that's kind of what I want to focus on today. All right? Now, let's just sort of make sure that we're clear, like what are engineering plans used for? They're used for a great many purposes. I think that taking a plan and taking a design and developing it into a coherent proposal is definitely one key use of a set of engineering plans. I would say the primary use, though, is probably the one in the middle, which is to communicate the concepts, the dimensions, the ideas between the engineer who designs the component, designs the system, designs the assembly, to those who are going to construct it, to those who are going to fabricate it, to those who are going to manufacture it. That the engineering plan set is really the communication mechanism, right? You all, and the thing of it is, as engineering students, throughout the 4 years of your education, a lot of times AutoCAD and the skills that we learn in this class seem like a footnote in a grand, 4-year degree program, because you all are going to leave this class and learn about thermo and fluids and strength of materials and manufacturing processes and hydraulics and all this engineering stuff that, you might go back and go, man, it's been a long time since I opened CAD. But really, at the end of the day, whether you're designing heat exchangers or pacemakers or retaining walls or what have you, at the end of the day, in order to construct those systems, in order to manufacture them or fabricate them, there have to be some sort of plan sets. That's really the goal at the end of the day. What do we want them to convey? We want them to convey materials, quantities, dimensions, locations, usually some type of instruction or guideline, and ultimately we want to see what the product looks like at the end of the day. Now, engineering drawings, there's really no way of learning how to navigate them without just looking at some, okay? We kind of need to look at some. We kind of need to look at some real-world engineering drawings and start learning how to review them. And I thought the best way of broaching this is to look at this. Let's look at the plans for the building, okay? The building that we're in right now, okay? And I do that because I think that whether you're a civil engineer, you're a mechanical engineer, you're a biomedical engineer, the truth is engineering schematics can be complicated. I don't care what discipline you're in. They can just be tricky. And the easiest way, I think, to discern or understand engineering drawings is to look at maybe something that's familiar. And everybody in here is familiar with this. So that's why we're using this as sort of our baseline, okay? Now, a couple things about the organization. So one of the things you'll find is that it's sometimes common for engineering drawings to not be organized alphabetically. Like, for example, you'll see the C sheets first, and then the A sheets, and then the S sheets. And it's not really because it's alphabetical, it's more about order of operations. Like, you're doing the civil work, then you're doing the structural work, then you're doing the MEP, then you're doing the fire protection or what have you. So the drawings are organized by the order of operations, as it were. Now, if you open Blackboard under week 7, you're going to see 2 sets of drawings, okay? You're going to see a complete set, and you're going to see an abridged set. The complete set is just that, the entire plan set for the building. And it's big. It's just, there's a lot there, okay? We're going to look at some of that today. We're going to look at some of this maybe on Wednesday. What I can tell you is that the homework assignment that we're going to have on Wednesday is going to be on the abridged set, not the complete set. Because the abridged set is just a few snap pages out of the complete set. Like, at some point, you just want to manage it, make the assignment a little bit more manageable. Now, for the assignment on Wednesday, I got no problem if you all work in teams. Like, you want to partner up, 2 or 3 together, work together, that's great. I got no problem with that. The way it's going to work is I'm going to give you all a printed out list of questions. So it might be like, what is the square footage of this room? And so you got to go to the plans and find that. And then once you find that value, you can enter that in the quiz on Blackboard. So I'm going to give you a physical, set of questions so you all can write that down and then enter them in later. So you'll look at the plans on your laptop and then enter them in when you're done. Sound good? Now, I want to give you some understanding of the navigation of what's in these plans. And again, I kind of like this because there is content for pretty much every discipline in here. Again, the biomedicals in the room, your drawing sets and the stuff that you would produce would be very akin to mechanical land. And this drawing set contains both mechanical drawings and civil drawings. So it kind of works out for everybody. But I kind of want you to get an idea of what the plans would entail. Now the first thing that you'll see in the plan set are the civil drawings, if you actually go through the volume. Because the civil drawings contain what would happen first during the construction of the building. So for example, we're talking about the existing site, demolishing the existing site, laying out the building. We're talking about grading the site. Does anybody know what I mean when I say grading? But what does that mean? I'm curious.
Making the land.
Say it again?
Prep the land.
Prep the land, yeah, the slope and the grade of the land, yes. Drawings that define where the utilities are, so we're talking about electric, communication, natural gas, water, wastewater, all that. Erosion and sediment control. When it rains, you need to control the earth and the dirt so that it doesn't get into the water system. All the landscaping, the trees, the bushes, the shrubbery, all of that is going to be in there. So here are some images of some plans, and we'll probably pull them up here in a little bit. So a couple things worth mentioning. So if you all want, I mean, I'm not stopping, you can go ahead and open them now. I've got here one of these civil drawings up. So a couple things worth mentioning. So first off, you'll see that the title block is on the right, okay? That's kind of common sometimes with sort of building type drawings or architectural type drawings, that all the title blocks and stuff and whatnot's on the right. And you'll see that the title block is much more involved than what's going on in, for our title blocks in this class. But the idea is kind of the same. Here, I'll pull up the civil drawings here. I'll do the complete ones. Let's do civil. Okay. So like, for example, if you look here, you'll see all of the different contractors and engineers and whatnot. So Bastian and Harris was the company that oversaw the entire project. And then we have a series of subcontractors. We have consulting engineers. We have, we've got consulting structural engineers. We have a lab consultant. We have the consulting civil engineers. We have a bunch of different subcontractors that would work on this. It is very rare that a project of this magnitude would just be left to one company. It doesn't really work like that. The contractors are going to sub out various components of this project to other entities. And it might even be possible that those contractors sub out again. So you might have subcontractors of subcontractors. Very, very, very realistic. So you'll have, some general notes about the project as a whole. Let's see, let's go down here. We've got our sheet numbering and sheet name here. We've got some various, north arrow and so on and so forth. I'm curious about a couple things. Let's see how everybody's, let's see your predictions here. So this is the footprint for the new building. I am curious, does anybody know what the term FFE means? They have an idea what they think that means. So FFE means 549.43. Anybody have a guess as to what FFE stands for? Curious. Anybody guess? Anybody have an idea? How about the first floor elevation?
Oh.
So if you're grading the land and these are the civil drawings that are establishing the site layout, once it's all said and done, we would want to know what the elevation of this point is, right? So that's what FFE stands for, is the first floor elevation, okay? Just wanted to throw that out there. And there's going to be a couple of other things that we see throughout the drawings here that sort of lead to that. Okay, so let's see what else is sort of noteworthy here. And again, like I said, we're keeping it pretty loose today. I just want to go through some basics here. Let's see what else I want to say. Okay, here we go. So let's take a look at this very first page within the civil drawings. We see this. Does anybody have an idea of what we're looking at here? What is this an image of? But it's a parking lot, yes, but more specifically, why would we put this here? Because this is what was here before, right? This was a parking lot. How many of y'all knew that? This was all one big parking lot. Why do you think we built the parking garage on 6th Avenue?
To make up for that.
To make up for all the parking spaces that we stole when we built the building. Did y'all know that? No. Well, now you do. You know? So we lost parking spaces at Marshall when we constructed the facility. So to offset the decrease in parking spaces, we put up a parking garage. Let's see, what else do I think is worth noting on here? I'll tell you something that's worth noting. Let's take a look at these. So we have a lot of section views right here. Okay, so what we're seeing here, and to be clear, we'll be able to discern a lot of these a little bit more later as we start looking at specific sections in the building. But I'm just picking one right here. Let's just pick this section E601. So this is amphitheater section A. So to give you a perspective, earlier in the drawings, and I'm being a little loose on this because I'm going to actually make you read the plans a little bit and answer some questions about this. I don't want to give you answers about the homework assignment before I've assigned it. But in this drawing set, there are a series of alternatives for various components that would go on the site. So spoiler alert, one of them was an amphitheater, and it's not here because they chose a different alternative, right? And you'll see what I mean when you start looking at the plans, and then you'll go, oh yeah, I guess they did choose that. But what we have here is a section view that contains some specific details that, should they have chosen to construct this, this is what it should look like. Okay, but let's just take a look at this image that you see right here. Tell me what about this image is something that you can't produce with the skills that you have right now. I don't know about you, but I see some lines, I see some hatches, I see some dash lines, I see some notes with some text, I see some Romanesque text, by the way. You know, it's like all that Romanesque text that looks like, oh, we never use that in the real world, and there it is, right? But in all seriousness, granted, this is, I'm sure some of you are thinking like, oh gosh, it would take me a long time to draw that, but do you have the skills necessary to draw it? Is there anything here that you've never done before? I don't think so. The only thing that you haven't done yet actually is, see where it says 6 foot? That's the only thing we haven't done yet, are the dimensions. And so we're going to do that next week. But other than that, everything that you see here is stuff that should be representative of skills that you already have. Make sense? So I just want to throw this out there that in the end, while these drawings might be more and more complicated than what we've done in homework, there's nothing different here in terms of skill set than what you've already done. Okay? It's just more time, you know? But hey, more time means you get to charge for that time. Money, money, money. All right. I like money. I have a feeling you do too. Okay. All right. Architectural drawings. Okay. This contains all of the information regarding the room layouts. And it does contain sort of the specific information about how the building should be finished at the end of the day. So we are talking about things like where the wall partitions are, the floors, where the windows go, where the doors go, the general plan for the furniture, exterior finishing. By exterior finishing, I mean brick facades, precast concrete panel facades, elevation views, and so on and so forth. And I will say that of all of the plan sets in the presentation, I think the architectural plan sets are the prettiest. They just are. They're the ones that really contain what the building's supposed to look like at the end of the day. Now, I'll show you something, and I think it's in the architectural plan set that's kind of nice, which I thought was kind of neat. Okay, so here's the architectural plan set, and if you start scrolling down, see this, these icons here in the very bottom? See the one here on the bottom right, and it's sort of this outline with like a gray square. You'll see that? And then if I scroll down to the next page, see how it's the other side of the square that's highlighted? Does everybody see that? What do you think that represents? What side of the building we're looking at, right? That's the side of the building that we're looking at. Okay, so for example, let's scroll down here, okay? So what do we got? We've got this side of the building. What do we see here? What are we looking at? What are we looking at here? Us. That's us. That's the classroom we're in, right? So this is dividable classroom. So here, if we scroll over here, what do we see? So here's the main entrance to the lobby, right? We scroll over, and what do we see? We see 1201, 1203. Sorry, I scrolled over too far. We see 1201, 1203. I'm curious, does anybody know? All right, let's look at dividable classroom. Let's look at 1201, 1203. Does anybody see this dashed line over here in 1201? Y'all see that over there on the right?
Yeah.
With the little triangle? Does anybody know what that is?
No, it's the middle on the back. The standard thing.
There's a screen right there.
Oh. Projector. Where's the...
That isn't turning on. Of course it's not. Dang it, that would have been really cool if it just
Where's
turned
the
on.
projector?
It just didn't.
Just the projector.
I don't know, maybe I'm supposed to turn it on here or something. I don't know.
Where's the projector?
No mic drop today. No, but yeah, we haven't installed the projector yet. We were actually going to try and install it right before the semester started, but we weren't able to get it done from an IT standpoint. IT was an all hands on deck for a new building on 4th Avenue. So we'll probably try and do that next year. What's that? Well, we're actually going to mount it like right there, you know, but alas. But, okay. But a couple things worth mentioning. So if you look here, so let's look at the dividable classroom. So let's just see if we can sort of understand what's going on. So this is where we're at right now. What's going on inside this little square right here? And why is there the letter I inside that square? You saw what I'm talking about? I'm talking about at the bottom right there.
There's a beam or a column.
That's these right here. And behind this, there's a steel column, right? That's directed upwards. And so if you wanted to know what that steel column was, go to the structural drawings. They'll tell you whether it's a W10 by 49 or a W12 by whatever. So that's what's going to be listed there. Let's keep on going through these because there's a lot of really cool stuff in these drawings here. Fit height. Okay. Because I got some really cool stuff I want to show you here. All right, so let's see. Let me see. First floor plan, second floor plan, canopy alternative, stair. See, first off, I just think these images are just really, really pretty because you can see cross sections of the stairs and whatnot, or what have you. One of the things that's worth mentioning as you start going through these drawings is we usually try and make the drawings as navigable as possible. So for example, if you look right here, let's just look right here for example, okay? So this is the 5th floor. Yes, there is a 5th floor of the building. The 5th floor of the building contains all of the MEP, mechanical, electrical, plumbing, the HVAC, the air exchange, heat exchangers, all that stuff. One of the things that you'll notice are this sort of legend right here. And so you'll look here on the left and right side of the building, and you'll see K, L, M, N, O, P, and so on and so forth. And then on the bottom, you'll see or column 22, 23, 24. So there's sort of a common grid reference for referencing the building. So as they construct the building, when you're on site, you might think, okay, this column right here is column, I don't know, H26 or what have you. So while constructing and whatnot, you'll have a common frame of reference and what have you. Let me see if I can find the furniture plan and whatnot, because again, engineering or architectural drawings, they get that detailed. So let's see. That's the, what's that? This is the, no, these are the ceiling tiles. Yeah, so this is that's a good question. So this right here, this is the 3rd floor ceiling plan. So you can see, I mean, it might sound silly, but somebody had to estimate how many different ceiling tiles they had to order for this project. Where are the ceiling tiles? Where are the lights? So like, for example, if we go over here, so we have the ceiling tiles, we have the vents, we have the lights, All that stuff has to be estimated and what have you. So, let's see. Let's go a little further. So one of the reasons why we had an abridged assignment is just that. We didn't want to like have you navigate through all of them, so just a few of them. I'll tell you what, I got something I want to show you. All right, so for example, a couple things I want to show you. So if you look at the individual classrooms, for example, so this is room 2121, you can see the square footage of the classroom. You can see the occupant load, the safe number of people inside the facility. But one of the things I actually want to show you is this drawing right here, okay? So this is a second floor plan, okay? And so we're looking at room 2121, so that's the computer lab here on the second floor. But what I've done here in this is I've zoomed in to this room 2121, and I want to ask you a specific question about this right here, okay? So this little icon right here, so it says F2A 5.09, there's another one right here, F3, so I'll sort of highlight it to you all over here. So we're looking at this icon right here. Does anybody know what that is? What do you think that's representing? Like, why is there an icon there? And why does it look like a big old arrow pointing to the right? Like, for example, if you look at the very, very top, there's another one with an icon pointing to the left. Does anybody have an idea what they think that represents? Anybody have an idea? Well, let me give you another simpler question. So where it says, like, A 5.04, what does A 5.04 represent, you think? Maybe A 5.04 is the page number? I mean, look at the very bottom of the pages, right? If you go to any one of these pages right here, I mean, look right here, here are the page numbers, right? A 5.09, A 5.04. Let me show you what these are, and I'm going to take you on a trip down memory lane.
Is it where you can see like closer up, more detailed stuff in that area?
Sort of.
Like what page it's on?
Okay, so you're half right. The answer is yes. So the A5.09, the F3, is a call out to what page that is. But what we're looking at is a section view. Okay? So, for example, we talked about this before, the idea that sometimes we want to see what's going on inside a part, right? So one of the most powerful tools is to cut a section. We break out the samurai sword or lightsaber if we happen to be a sci-fi fan, and we cut a section inside. And we showed an example of that where if we had some crazy machine part and we wanted to see inside it, that we would actually cut a section and we would investigate what it looks like inside. And remember, the symbol was we would have these sort of arrows that pointed in the direction that we're looking, okay? So I propose, if we go back to these drawings of the building, and I ask you, what are these section views right here? They're sections of the wall. That if you cut through the wall and look at the wall, what are you going to look like? Let's go to that page. What is it, A5.09? So we're on page A5.09. Let's go to view F2. And what are we seeing? We're seeing a wall section. So this is what the wall actually looks like in the building. Okay? So what do we see? We see these, let's look off to the side. We see these targets that say first floor, second floor, and under the targets there's a number, right? So under the first floor target, it says like 100 feet, and then under second floor it says 116. Those are elevation differences between the first floor and the second floor. So for the architect, all the architect cares about is how tall it is from floor to floor. So they just set the first floor for the architecture drawings. Let's just keep the first floor at 100 feet and go from there. Well, we can see, so what are we seeing here when we look at this? We see the brick, we see the insulation, we see the wall studs, we see the beams, we see the slab. This is what we're looking at inside the building, okay? So not only are we seeing the plan view of the building, but we're seeing various section views that are necessary in order to fully construct the building. Does that make sense? And so that's what those are representing, okay? So So yeah, let me pull this back up. So again, we've got a lot of other really, really cool detail views. I'm sorry, I just find this stuff really, really pretty. So we've got views of the section views of the building, the views of the stairs. These are the stairs inside the lobby. Random factoid for you, one of the reasons those stairs are so darn massive is because if they deflect too much, you'll crack that tile. So, random factoid for you. That's why they're so big. We see elevation views of the outside of the building. And again, as before, if you look on the side, see those little targets, the little black and white targets there on the side, on either side of the elevation view? Those are the elevations of the building. So maybe, I don't know if you knew, but it's 16 feet from this floor to the elevation of the next floor. So how do I know that? Look at the plan. That was the design. So again, and here, here's the furniture layouts. This is room 2121, and we can see, if you go into room 2121, that's actually kind of what it looks like. There's desks and both perimeter around the room and desks in the center. I'm not actually sure if the floor plans include furniture layouts for this room, because this room I know during the conceptual stage was meant to be moved around. So I'm not sure what it says there. Okay. So far so good? All right, so the structural drawings are, so the structure of the building is the component of it that actually keeps the building from falling down, like in short order. So we're talking about the foundation, the framing and the walls, the concrete slabs, the structural columns, the beams inside the building, the stuff that keeps the building from falling down. That's what's going to be inside the structural drawings. And just so you're aware, the structural drawings can get pretty voluminous. I only gave you a couple of pages on the structural drawings for your abridged assignment, or for the homework assignment, because I'm really going to only ask you some questions about the foundation. Okay. There are going to be a series of drawings, which I don't think we're referencing on the homework, but I did want to mention what's called fire protection drawings. So this is essentially the sprinkler system, okay? But it can be beyond just the sprinkler system. I got an example worth mentioning. How many of you have parked your car in the Pullman parking garage? Anybody? Have you seen that stuff on the steel beams? Kind of looks like oatmeal. They spray it all over the steel beams. Y'all know what that is? That's fire protection. That is there as insulation to prevent the steel from suffering too much adverse section property loss because of thermal loads, because of fire. So it's there as insulation. So random factoid for you. That's what that is. So if you actually look in some of the guts of this building, you'll see some of that stuff sprayed around the beams and columns here as well. So, but that's what, if you ever looked at steel beams and columns and wondered what that oatmeal stuff looking is, that's what it is. Random factoid for you. Okay, the plumbing. Water, wastewater, ventilation. Obviously the biggest, I would say the biggest plumbing needs for the building center around the restrooms, but it's not just the restrooms. So if the restrooms are one of the biggest plumbing needs for the building, what's the other biggest plumbing need for the building? Beyond fire protection. There's another big aspect of this building that needs adequate plumbing. Well, okay, so the roof wouldn't really involve the use of water lines, but it would have like things like stuffers or drainage or what have you, but not pressurized water lines. There's another entity in this building that needs water.
Labs?
The labs, exactly right. All the biology labs, the chemistry labs, all that stuff needs water as well and what have you. And there's all sorts of other aspects that these plans can help us navigate. Like as an example, a common thing during plan review is, are we going to be erecting a building that is ADA compliant? Y'all know what I mean by ADA? What does ADA stand for?
American Disabilities.
The American Disabilities Act. So things like, do all the doors have door openers? You know, is there ingress and egress out of the building that meets ADA requirements? Why is that ramp from that door all the way down here so long, right? Because it has to be at a certain slope for wheelchairs, right? All that stuff has to be vetted before the building gets erected, and that's what plans can help us do, okay? So here we can see some close-up views of the bathrooms and whatnot. It's got to be worked out, so. But one of the things worth mentioning about this So, I mean, there is a reason, by the way, there is a reason why are the men's restrooms and the women's restrooms next to one another, right? And the reason why is because we can contain all of our plumbing needs in one location, right? Reduced amount of linear feet of pressurized water line in the building. So not only does it kind of make sense from a building layout perspective, it also kind of saves money on plumbing and what have you. It's just the truth. Here we see another set of specific section details. We see water tanks, clarifiers, what have you. And again, all of these section views, if you start zooming into them, hatches, lines, arcs, radii, trims, offsets, all the same components that we've been looking at. Here we can see pipe gallery views of the various plumbing lines throughout the building. I don't really want to get too far into it. I mean, again, you could sit here and say something about every single one of these pages and start going nuts. All right, for you mechanical folks, I don't know if you knew this or not, but so I'm a licensed professional engineer, and there are avenues to get a licensed engineer for both civil engineers and mechanical engineers. Mechanical, so the way the PE exam works, have y'all heard of the PE exam and FE exam?
Yeah.
Okay, so the way the PE exam works, you pick your discipline and then your specialty. Okay, so for me, I picked the civil engineering exam, and my specialty is as a structural engineer. I design bridges, that's what I do. For mechanicals, there are 3 specialties. The first is machine design. The second is thermofluids. You know what the third is? HVAC, okay? HVAC and refrigeration is one of the most common licensed specialties for mechanical engineers. A licensed mechanical engineer was one that designed all the heating, ventilation, and air conditioning for this building, okay? So that is a common job prospect, a common avenue for mechanical engineers. And so you will see that the plans contain all of the necessary vent sizes and pump loads and so on and so forth for your heating and cooling system and what have you. Obviously, this building has miles and miles of wire and cabling and whatnot. I see these electrical plans and they just sort of scare me and whatnot. I know that when you hit the button on the wall, the lights come on. That's about all I know about electrical engineering. Okay, that's a joke, not very funny. Okay, I just want to highlight a couple of the details and whatnot that you'll see in the plan. So here we see an example of a footing detail. So you know what a footing is. What is a footing, by the way?
A footing?
Yeah, what is it?
What are footers?
First off, it's footing. We don't use footer. It's footing.
It's like the concrete thing that goes around where the walls are going to be.
So it is the connection between the building and the ground, right? Essentially, right. So it is the mechanism that transfers the load to the ground, and it is part of what we would call the foundation. Okay. I know that they are referred to as footers, but the technical term is footing. So I might use the term footer though every now and then, so I can't hold too much against you on that. You might also see this. So this is something that we might discuss a little bit later, or we'll definitely have one homework assignment on, where I will give you a 3-dimensional rendering, and I will say, based on this 3D rendering, develop a front view, a top view, and a right view. So I'll give you that and make you draw that out. But it is not uncommon to see both plan views, elevation views, and section views like that. The only other thing, and here's a view of the parapet wall. This is what you find there on the roof. The only thing that I think is worth mentioning beyond what you've seen here is that the drawings will typically contain some sort of legend. So like as an example, if you look at the electrical drawings, you'll see stuff like this, and you'll see, okay, this is a switch duplex, this is a toggle switch, this is a 3-way switch, 4-way switch, and so on and so forth. And you will see those throughout the wiring diagrams. When you look at the wiring diagrams, I'm sorry, I'm just not that good. I've seen, I go, ooh, if there's anything that overwhelms me sometimes on plan sets, it's electrical drawings. I don't have the mind for it. I can't really see it, but that's why I went to civil. But You will see typically a legend set that will define what the symbols are. You see that in the architecture drawings as well. So for example, the architecture drawings has a series of hatches, and what do those hatches represent? Is this earth? Is this concrete? Is this wall section? Is this steel? So on and so forth. You will also see general structural notes. You'll see that, and you'll see notes and specifications throughout the entirety of the plan set, what specifications you're going to follow, some general guidance on construction. So a good example of that would be concrete cover. Y'all know what I mean? What is cover? Y'all know what that is? Y'all know what that is? Cover is the distance between the rebar and the face of the concrete, and so that can affect rust and corrosion of the rebar. So if you have rebar that is going to be exposed to the elements, it might have higher cover requirements than stuff inside the building. So you'll find some general guidance on, hey, if you've got an element that's going to be outside, this is what the cover needs to be, and so on and so forth. And then here's some more general renderings. This is maybe probably more what you would see on residential, like if you're drawing up plans for a house, like this is maybe what a kitchen would look like. One other thing that you'll see in the building, and in the plan sets, I'm actually going to have you look through these, are like door schedules and window schedules. So instead of drawing all this stuff out, you'll just see plan set or tabular data. Here's the size of the door in 1203. Here's the size of the window in this room. Because after a while, they're all the same, and really what you just need is a list of stuff that you need to order. Any questions? All right, I threw a lot at you, and like I said, today's going to be a little bit loose, and this week's going to be a little bit loose. What I'm going to do on Wednesday is give you all a sort of formal assignment where I'm sort of making you look at these plans. I think the only way to really understand engineering plans is just be forced to look at them a little bit. And then once we've looked at them a little bit, we'll take that context and maybe ascertain what to do with them with dimensioning and whatnot next week. That's all I have, everybody. I will see you all on Wednesday.